guys, today we're gonna learn about the Wilcoxon Mann-Whitney U test. Introducing Group 3's presenters, Mashita, Akilah, Faiza, Hazira, and also Anis Natasha. What is the purpose of Mann-Whitney U test? The purpose is to test whether the medians of two unpaired sets of measurements are different from each other. So this is some history about the inventor of the test. This test was invented by Frank Wilcoxon in 1945. He is a chemist and also a statistician. He also known for development of several statistical tests. And the most well-known paper is Wilcoxon rank sum test and Wilcoxon sign rank test. There are three steps to make hypothesis. The first step is to state the null hypothesis and the alternative hypothesis. The null hypothesis, the median of the two samples are not significantly different from the zero. Alternative hypothesis, the median of two samples are significantly different from the zero. The second step is to read the significance value. If the significance value is smaller than alpha, so the null hypothesis is rejected. But if significant value is larger and same with alpha, so we fail to reject null hypothesis. Step 3 is make decision and conclusion. This test also can be used to test whether experimentally treated organisms are different from controls, and also can be used when some species is different from another, and also can be used to compare the numbers of ground beetles in two different treated fields.
This test is used to compare two independent groups of sample data by comparing their median when we have to test two populations that are identical. It is also best known as rank sum test, Wilcoxon test, Wilcoxon rank sum test, U test, and also Mann-Whitney U test. The test statistic for this test is capital U, and it will be compared with critical values for U at the table based on the sample size of each group. This test is also used to assessing if one of the two samples of independent observations tend to have larger values than the other. And this is how we wrote hypothesis testing for this test. For the null hypothesis, the equal sign indicates that there is no differences between both groups, while for the alternative hypothesis, it is vice versa.
So next is Wilcoxon Mann-Whitney test procedure. First, assign ranks Ri and 1 and 2 to the sample observation. If unequal sample size, let N1 refer to smaller size sample. Smallest value equal to 1. And secondly, sum the ranks Ri for each sample. And thirdly, test statistic. Null hypothesis, both samples come from the same underlying distribution. And this is the equation of U. Compute also N1 and 2 minus U. If this expression is larger than the above U, then this becomes the final U statistic. At N greater than equal 20, U begins to approximate T. So, the test statistic change to a T value. For convenience, take the smaller sample as the first sample. And this is how to find the mean and variance of the sampling distribution of U statistic.
Here is an example to help you understand on how to use Mann-Whitney U test. Is there statistical evidence of a difference in Apgar scores in humans receiving the new and enhanced versus usual prenatal care? In order to know, we run the test using the 5-step approach. First, we will start with the hypothesis. It consists of two null hypotheses that state the two populations are equal, and alternative hypothesis that say the two populations are not equal. And the level of significance that we use is 0.05. Now, let's test our hypothesis. Next, we have to select the appropriate test statistic. Because the measures are not normally distributed, so we will use Mann-Whitney U test. The equation is as on the slide. The test statistic is U, where R1 and R2 are the sums of the ranks in group 1 and 2. The appropriate critical value can be found in the table on the right of the slide. We have sample size of 8 and 7, and we got that the critical value for this test is 10. So the decision rule is reject null hypothesis if U is below or equal to 10.
Step 4 is compute test statistic. Arrange the order from the smallest to the largest. Next, assign rank of 1 through 15 to the smallest through largest value in the total sample. There would be 50 rank because there are 50 samples. Next, sum the rank in each group. This is how to assign rank. From the arranged sample, the smallest score is 2, and there's only one sample for 2 score. So, the first rank would be the score 2. The biggest score is 10. So, the biggest rank, which is 15, going to be at the 10 score. Next, the score 3 would be in the rank 2, while the score 5 would be in the rank 3, because there are only one sample for both of these score. The next score is 6, and there are 2 samples for this score, which is at rank 4 and 5. To determine the rank for this score, these 2 score, we need to sum both 4 and 5 rank and divide it with 2 because there are 2 samples for this score. 4 plus with 5 equal to 9 and divided with 2 will equal to 4.5. The rank 6, 7 and 8 are occupied by the sample with the same score, which is 7, and we need to determine the actual score for this sample. We need to sum the rank 6, 7 and 8 and divide it with 3. 6 plus 7 plus 8 are equal to 21, and divided with 3 we will get 7. So, the score 7 would be in the rank 7. The step to determine the rank for score 8 and 9 are the same as before. We need to sum the rank 9, 10, 11 and 12 and divide it with 4 because there are 4 samples with the same score, which is 8, which is equal to 10.5. For rank 13 and 14, we need to sum both of these rank because the samples are the same score, which is 9. 13 plus 14 equal to 27 and divided with 2 are equal to 13.5. In the usual K group, the sum of the rank is R1 equal to 45.5, while the new program group is R2 equal to 74.5. The sum of the rank will always equal n plus 1 over 2. As checked on our assignment of rank, we have n plus 1 over 2 equal to 15, 16 over 2 equal to 120, which equal to 45.5 plus 74.5 equal to 120. Next, we compute U1 and U2 using the formula. The calculated test statistic for U1 is 46.5, while for U2 is 9.5.
The critical value shows that the test statistic is 9.5 and it is below than 10, so the null hypothesis is rejected. This shows that the population of Apgar scores are not equal in women receiving usual prenatal care as compared to the new program of prenatal.
That is all from us. Thank you for watching.